Okay, hey, 5.3 mountain formation. Exciting. What we're going to do is talk about and identify the different types of collisions that build mountains. And, we're going to talk about the different types of mountains. And so when we look at mountains, there's so many different types of mountains out there. But when we look at mountains that have the same area or general shape and structure, we call it a mountain range. And that's not really a hard stretch. We can talk about things like the Himalayas or the Cascades or uh, um, mountain chains that are or a mountain range that are in a particular area. The next one we'll talk about is a mountain system. And so many of you have been down in Tennessee and Kentucky, and these are several different mountain uh, ranges. And so you have the Blue Ridge Mountains, the Smokies, the Cumberlands, um, even the Ozarks. And when we talk about Appalachia, the Appalachian Mountain System, and so you think about the Adirondacks and the different mountain ranges. So each of them make up a giant mountain system. So it's these adjacent mountains. And then you've got the belts, right? So this is the Pacific Ring of Fire, also the Circum-Pacific Mountain Belt. I wonder why the Ring of Fire and the belt are in the same place. Well, it makes sense. Tectonics, right? So mountain belts are the large mountain systems, a group of systems. And so the Eurasian Melanesian belt is one that is not in a circle, but definitely in a large chain. So how do tectonics work? It's real simple. You either go up, you either go down, you can move apart, but to understand how it all works, you either have with convergent plates, one is going under or subducting, and one is going over. And what we see is in these areas a lot of volcanic activity. So when we think about the Pacific circum circum Pacific belt, um, essentially we see that subduction causing the development of volcanic systems, and it's pretty easy to see. If we look at a collision between a continental and oceanic, so back here, this is oceanic crust, this is continental crust. What ends up happening is the ocean crust, it goes under, right? And so we see lots of magma, lots of volcanoes, the Cascades clearly along the west coast. And so, but every once in a while, a chunk of this ocean crust gets caught. Um, and we call that microplate terrains or terrains. And basically, this piece just rides up. It just doesn't quite get the idea that it should go under. Um, if we have um, if we have collision between oceanic and oceanic, then definitely one is going to subduct under the other. And what do we get? We get volcanoes. So we see these areas in the middle of the ocean. If we see crust and crust, so India or the Himalayas are formed by India colliding in to Asia or Eurasia. And so we see this really quick uplift. And so lots of earthquakes, lots of vertical uplift. That's why someone who climbs Mount Everest today will have climbed the highest, whereas you know, yesterday they were at the highest. It's just always going up. Look at this. Look at this anticline and syncline right here. So gorgeous. Anyhow, so if we have a folded situation where we see deformation and the mountains are being pushed up because they're compressing, we call that a folded mountain. Folded mountain. A plateau. This is just a large area that's been vertically uplifted, and so this whole chunk right here is went up, and what's happening is it's still flat. It's not a mountain, but it's found near the mountain. So this is a plateau. Fault blocks are pretty easy to see. What happens is they spread apart. So this is a divergent boundary, and the middle piece just slides down. So you can see it right here. This piece went zip straight down. This is called a fault block mountain. Here's a fault block right here. Good to see. Doop, straight down. The area, this piece is called a Grabins, and so it slid straight down after it slipped. So the piece used to go straight across, and when it pulled apart, zip, zip, this is called a Grabins. The piece that stays where it's at is called a Horst. Hotspots are pretty cool. When we have volcanic mountains, basically lava comes up and it then hardens, right? So it moves up, hardens, moves up, hardens. And so a lot of times what happens is we see magma solidifying and the crust underneath it moving forward. So we see like the Hawaiian Islands. The Hawaiian Islands are these little blips of lava and magma that come to the surface, and then the crust is slowly moving underneath it, and so it's kind of like acid reflux, right? So you have a little pocket of acid reflux, forms a mountain. The crust then moves over hundreds of thousands, millions of years, another blip of a hot spot, and so it just pop up, pop up, pop up, pop up, pop up. Dome-shaped mountains, right? So here's a dome-shaped mountain. These are dome-shaped mountains, not the fact that they come with president heads on them. But basically, there was a big mountain area that was built through magma, and then all of a sudden, Iron Mountain in Atlanta, by Atlanta, is a dome-shaped mountain. Here's a great divergent, right? Here's Dixie Valley, and what happened was the fault separated, zip, and this guy's house went. I'm not sure if he sits in this chair or not. Here's another good example of a fault, right next to it. You can see it. That's the fault. Again, right here, it just slid down. This is the Teton fault. Again, fault block. So this valley area is flat. You can't see it over here. There's a mountain over here. Nice golf course, though. Here's a perfect example. Slip, slip, right? Fault block mountain. And then, look here. I mean, this is pretty evident. Slip, 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 right? Another one. Slip, 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 slip. This is the subduction zones from oceanic crust to continental crust. The San Juan de Fuca plate, San Andreas fault. You can see why this is right here. This plate is moving northward, and the North American plate is moving southeast. And so you see this moving, and Los Angeles is in the way. San Andreas fault. You can see it right there. Good example right there, same thing. San Andreas fault. Oop, that's San Andreas right there. Here it is too, straight up and down. Here is in New Zealand, these volcanic mountains. All right, we're done. Hey guys, thanks for being so awesome. Appreciate you. Hope you're having a great day, and we'll catch you next time.